Hi, welcome back. So today we're going to talk about the upgrade version of the Room Propagator 2. If you remember from our previous video, the objective is that we have a already modeled uh, standard. Here is a classroom. The objective is to duplicate this layout and apply it to all the other rooms we have here, regardless, and have them uh, basically scattered around the room and follow the room's orientations and shapes, so on and so forth. So we're doing that by using these generic annotations. We create one inside the rooms following the direction of the room and pointing where the door is. And we have all of these equipment devices in the room um, have the same project parameters to match with the annotation descriptions. Once that is done, come here and run. And it places all these equipment in those rooms. The first times we may see some of these desks are in the middle of the room. It's okay. Run this again. It will try to correct itself. Okay, now it looks better. And so we have here these models, and should we decide to delete anything or move anything around or move it around and decided to lock the position, if we were to run this again, it will move the other things that hasn't been locked, and it will place back the chairs that we deleted. So establish the parent-children relationship between the source and this model. See, the chairs comes back, that has been moved away, and this one stays the same location. They're all going to match what's in here. Similarly, if I delete things in here and delete a tag, and if we're to run it again, it's going to delete the middle section of the chairs and delete everything in this room. Okay, now there's going to be an upgrade, and our upgrade is that, as you can see here, now I've placed doors in the room. The upgrade is the ability to align things to the door. I have a classroom and I have here a name tag and the in-room control panels that are supposed to host around the doors. I'm going to select these two and check the door host. And then I want these two desks to stay together regardless of how long this room is or how wide this room is. So introducing another one called host element ID. The way I do is get the ID of this and put it in here so that the second desk will be hosted on the first one, and get the ID of the standing desk, host it, push it into the chair so that the chair will host on the standing desk. Now once that is done, you can see that I have doors in different locations of the room and in different wall of the rooms with different uh, sides. It's okay. Once you select the door host, it's going to automatically align to the doors. This is still in the middle. Let's run this again. But you can already kind of see that there, that control panel, that touch screen and name tag is aligned to the door. And here, like, it's in those locations. It's to the side of the door, over here, and over here, even it's far away from everything else original location. Plus now these storage are perfectly close to each other. The position between the standing desk and the chair are all the same, even though the rest of the chairs and the light are scattered around the room. This relationship has been retained, and the element aligned to the door has been hosted on the door. So that's the two features we added from our previous design, namely the door-oriented and the element-oriented that we said will be the new features uh, that is going to be developed. Now it's there. Okay. Um, talk a little bit about how this is achieved. Hopefully, we can walk through the whole process this time. So if we come back here, again, we first start this by processing this parent room. We do so by slicing this room into many dots, which is controlled by a number. The more we give it, the more dots it's going to have. So basically we slice this room into different dots. And for all the other rooms that have the same ID, the same annotation ID, we're going to slice them with the same amount of dots. So regardless of the size of the room, it's going to have 10 dots on this direction and 10 dots in this direction. So just like that. The orientation of the dot are controlled by the annotations. If I rotate it, the dot is going to rotate as well. This is a little bit too much. Let's delete a couple ones. Now once we have these dots, we're going to find the location of these elements. This one. See that let's go to the 3D view. There's the position dot for all of these furnitures or lights or equipment, and use their corresponding index in this grid system in this room. We're going to match that into all the other rooms. So those will be the placement dot following the same kind of structure. Let's see. I'm going to keep only this trash can. So there will be only one dot in this room in the top left corner. This is obviously controlled by the annotation ID. If I were to flip it, it's going to come to that side of the room. So because it's reading the index, it's from the index of the grid. If I flip it, the grid is going to start counting from the other direction. And if I rotate it, it's going to count from the other directions again. Now it goes outside the room. Bring it back. There. So once we have done that, use this to track the placement and start to place things and move things away if they are too far away, so on and so forth. Now let's talk about the ones that host on doors. So you see, the starting point is that we use them to calculate their supposed placement point, regardless of if there's a door or not. For example, that's the point when they're not door hosted. And because they are door hosted, we use this dot to start finding um, the nearest door it is. Oh, yeah, I need to turn this into door host. Once we turn that on, it's going to update the dot to be here. So it's using that 2 point to calculate this 2 point. Now obviously when there's 2 doors in the model, it's going to use that 2 point to find the closer doors it has. So if I move this over, it's going to move that 2 dot to be over here. Yeah. Plus it's using the direction of this openings to control the side of this. So basically if I were to flip this, the dot will come from those 2 dots to be over this side. Yeah, basically you can see it's there now. So it's always going to be on the handles side. But it doesn't recognize the direction of this door. So it's calculating the inside and outside of the rooms. So flipping it on this direction doesn't impact the calculation. It's still going to maintain the same kind of relationship. And it's reading the size of the doors, changing it to a bigger door will automatically update the position point to adjust to the width of the door. And finally, should there be no doors, it's just going to go back and place it over this point. Yeah, it's going to go back to this point. But as long as there will be one door, it doesn't really matter where they are, it's going to just go to that door. That is a way worse position. There's a projector in there. There's a projector screen in there. So we're still going to put it over there. Close down the doors. And finally, when it comes to element host, so basically I'll have to rehost this, get the ID of the one and push it into this one. Get the ID of standing desk, push it into the chair. select these 4 devices, make them to have the same marker. And then they will just come in. I'll have to preview the point. So there's the trash can, there's the first desk, and then there's the standing desk. There's the first storage in those locations. And it's going to use this dot and the vector from the first storage to the second storage to calculate the position of the second storage. I think it's this one. If I preview it, see it pops up in there. Now there's the first storage, the second storage, the desk, and then the chair. Again, the direction of these is controlled by the annotation ID. So if I were to rotate it, it's going to move everything away. Now there's that standing desk, there's that chair, there's the first storage, and there's the second storage. These annotation markers really defines the orientation of the building and everything, the relationship of everything. So now the position of everything has been calculated. It then comes to just place those things and update them to have the same parameters, update the rotations, the instance parameter, product parameter, height, so on and so forth, which is pretty much standard from there. So that's the whole process. Now, if we come back to here, find the room with the same annotation, place grid dot, find the source grid indexed, find the target location with the same index, and then create element. And then somewhere in here, calculate the door orientation positions and the element orientation positions. Then follow the same rest of it to move things around walls or to update parameters. Basically, that's the whole step. Now, pretty much that's all the tricks. It dealt with many problems when we involve additional informations, the existing of doors, for example, and then the relationships of equipment inside the room. However, there's still one thing to point out. I have this host element and feasible check. So when we talk about host element, and the process we do is put the other element ID into the parameters. So it's going to be tricky sometimes. We're going to potentially create risks. For example, this, however, is just a way of putting things in there. If I can host this element on another one, and in return host it on that one. Now I create a loop. If I go set value, it's just going to point me with errors. It says these elements have sequential or looped host relationships. Now, we know that this is going to create a loop and therefore it becomes wrong. So it's going to alert me and highlight these things so that I know I should fix it. It is important to not create loops or create something like sequentials, meaning one is host on another one, and then another one's host on the third one. Or even to say host something on a element completely outside the room. They're both going to raise alert, like they host on the ones that with different element ID, or there is a loop. Basically, these are all elements that need to be fixed. This is going to highlight them so that we know it should be changed. Basically, whenever we introduce a new way of calculating, there's going to be some risks, and all of these risks need to be prompt for avoid. Otherwise, it's going to break the script or make it uh, unrunnable. If we fix everything and we're just going to run this, not do anything, we don't have to do all of this. It's going to check the result. Once that's all good, we can go on and run that. And now it's coming in correct. Well, it's still a little bit off when things are previously vertical, now they snap to the walls, so this is a little bit overlapping. But that's minor. We can move them manually. For the majority of these places, it's going to come in right. This one hasn't been hosted, so the chair is slightly off. But that will be all. This is actually a reasonably complex things. If I were to showcase all of this, it is a super big and mass script. Mostly because once we introducing the door host and element oriented, we'll have to deal with different scenarios. What if there's no door host element? What if there's some door host element? The room with one door, the room with multiple doors, the room with no doors. What if every element is door host? And the same goes for the element host. What if there's a loop, sequential, host on wrong IDs is going to check in the first steps, and after that is going to basically this is the whole steps calculating point all the way until here is when you start creating an element. Previously, this whole complex mess is to accommodate different scenarios to calculating the placement point and the rotation for individual atoms. But the end result is good. Now we have a very easy way of duplicating multiple devices across rooms and have them adjust to the boundary of the rooms. So you see like here, even though the room is smaller, it still try to place the chairs inside the boundary of the room instead of going like away from the room. And more importantly, it keeps updating everything. So should we make any changes and run this again, it's going to propagate those changes in the rest of the rooms, allow us a very easy way to keep updating our model to reflect the latest design. Come on. Yeah, the chairs are gone. Now there's only one in front. Okay, that will be all. Thank you.